Hello friends, in continuous of machine learning series, this is regarding the regression. This is the one of the algorithm for supervised machine learning. In my last video, we have gone through the classification method. So here, this is the regression. So ultimately, if you're talking about the regression, this is um, this is the prediction mechanism where we have one variable, and on the basis of that value we are predicting the other on the real time. So when the data is like continuous data, and if we want to predict the output as per the input values, then we use the regression method. So how, suppose we have a data in some intervals, and we just want to predict the value of output in between the two intervals input. So in that case, we have to fit the curve, and according to that, we have to say, hey, this is my output for exact output for this input. Okay, so let's see. So we can see regression is nothing but a continuous process where we can see the input value, and corresponding to input value we have to take a output. But here the things are, we have the points or the data points that is very irregular, scattered in a 2D graph, if you can see here. So let's see one example. We will see one example with the help of some handwritten things, then you can understand the properly. So see, suppose this is my like x-axis, this is my y-axis. You can say for now this is my y-axis, this is my x-axis. So here, suppose we will take one simple example. Regression is nothing but the relation between the two variables. One is dependent variable, one is independent variable. So suppose um, I'm just giving on x-axis the square feet area, area in square feet of any plot or flat or something like this. So this is the area. This is in square feet. You can say it's an area. And what is this? This is the price. So according to area, we are just predicting the price. But the problem is, um, we have the data point like this. Suppose first we divide the interval. Suppose this is 50 square feet, or we can say we can take the interval of like 500 square feet. This is the 1000 square feet. This is 1500 square feet, and something like this. Something like this. This is the 2000 square feet. We can take multiple here. So, and this is the price in the Indian rupees. We can say it's in Indian rupees. So suppose 500 square feet, like some, for an example, 15 lakh rupees, or here um, 15 lakh rupees, we have taken the interval 30 or 45 lakh or something like this. Depends on the area. We can calculate the, suppose this is a 60 lakh, or then 65, 70 something. It will keep on increasing. So while we have this data and this point, we can directly predict, hey, this point we can directly, when the 500 square feet area is, it is a 15 lakh. So, but what about this? What about this? When the area is 750, approximately the middle of this, then there is no point. So if you have a straight line, then directly you can say, okay, so if this is in a straight line, so you can just calculate and see this is the lakhs in Indian rupees. But what about if you have point like this? This is 1 point, 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 something like this. Means the data is scattered. So in this case, how you do, because this data is not in regular shape. There is no mathematical relation between this area and the price. So how you can at least predict proper answer while you are giving some input? So if you can create like one straight line here, this is straight line, but this is not getting touch. So if you can see, this is 750 and you are giving here. So for this point, if area is this one, this price is false. This is because this is a huge difference between there. So for this we have to make one curve, and that curve should be pass the minimum distance from these points. So how we can do these things? So we will pass the multiple lines here. We will pass the multiple lines like this, where the maximum um, points can cover. So that line we have to identify, because it's in two variable only, and these things are very near to that. So we are considering that this might be fit for a linear relation between input and output. So that is why we are taking as an straight line y equals to mx plus c. In form of that we are taking. So we multiple lines we can take it here. So how we can see which line will be more relative in between the area and the price? So for that we will draw one line, exact line where the all point might be passed, and from that line we have to suppose we are talking about this line, first line. So we have to take a difference of distance from all the points from this line, all the distance from this line, all the points distance from this line, not only this, the bottom one also. So all the points distance we are taking from first line, and there is one formula we can say. So if we are considering this is a delta difference, so we can say summation, we will add everything. So suppose there is a n number of points, so we can say j equals to starting from 1 to n, and we can square the delta value. Subscript we can say it's a jth value, and square this value means this value, this value, this value, this value, this value, this value. From one line we will square, then add from 1 to n, and we will fetch some number. This is the difference 1 or delta 1 we can say. Then for every lines, line number 1, line number 2, line number 3, line number 4, line number 5. So every line we will see every point with this formula, and we have now multiple distances, multiple this summation of del. So we will see which summation is having the lesser value, smaller value. So suppose line number third, this line is having smaller value of this formula for all the points. So we will consider in this case this third line will be best fit to explain the price of a square foot area according to this. So suppose this is line we are selected because of this formula is having the minimum value. So this line we will consider as a like a maximum fit for this relation. So for this, if we take any point here, and we will see what is the like a price for this, we will go blindly and we can see. This is not exactly what we want to do, but yeah, there is a prediction because this is a regression model. So in the same thing we will do in our next video while we are solving with the programming. So same thing we will do. We will import some data area, and we will predict the price. So we will use the Python libraries, and we will give this data, and according to this data we will see the price, and the line also we can see it is behaving like a where the delta value will be the minimum value. So this is nothing but a, we can say it is an equation y equals to mx plus c. It's an equation in one variable, where here this x is a independent variable and y is a dependent on x. So this x is nothing but in this case is the area, and y is nothing but a price in this case. So it is straight line we are using here, but multiple line we have used to find the global minimum value. Okay, so that is why we are taking this for this curve, and we are taking the straight line. We are trying to pass that straight line. We are trying to find a straight line where the maximum point can be covered, so that we can consider that line best fit for this situation, and we will find that line as a regression model for this. So regression model is nothing but a equation in one equation in two variables x and y. The same regression model we will use while we are training our model inside the Python code, right? So from the training data, while it is going to train, we are testing the data with the help of same data set. Then we will predict with the help of new data. So approximately it will give the proper answer, and we will adjust the parameter according to the function provided by pandas library or the models, and we will see how the accurate answer is given by the model. According to that parameters we will fix there, and our model will be fixed for this situation, and we will take the output as per the fitted model. So this is the complete overall, we can say it's explanation about the regression model, and it is using very simple problem. We will see this program in the next lecture. So please keep continue watching this video, and please subscribe this channel, so that once the new video is coming, you immediately will get a notification. And please share to your colleagues also, so that they can also understand the things. Thank you.